Hello again, I'm still the Alexey and here is still the MGC. So this is the third video of our Spring EOP journey. In our first video, I explained you how to write the aspects using the Spring EOP and what you should know and what you should remember when you do this. In our second video, I explained the internals of the Spring EOP. We took a look at how the CGLib proxies and GDK dynamic proxies works with the Spring EOP and what all those magic do under the hood. And in the third video, we will take a look at the examples, how the Spring itself and the other libraries use the Spring EOP to achieve their goals. So it's always hard to start from the scratch when you try to do something, and with writing your aspects is also applicable. So we will take a look at the examples, and you will always know where you could gain some more experience on how to write the aspects with the Spring EOP, and you will have the reference how to do this. So let's stop talking and go to the code. So we will use a really small project as an example, and here you could find the most common Java application with all those parts. So we have the Spring Boot application, some beans in our configuration, main method with the Spring application. We have one really simple MTT book which has only ID and name. We have the repository for this book. It's GPA repository, so it's Spring Data GPA. Also, we have the service which use this repository and declares some methods how to work with it. We have the transactional method, we have the scheduled method to execute something on schedule, and so on. Also, we have the controller here. We have the endpoint which starts from the books, and several endpoints with get and post mapping. So let's take a look how this works. So I already started this application, and first of all, we can take a look at the console in the browser. In the browser, we have the special path which navigates us to the H2 console. So in our project, we again use the in-memory database H2. So here we could connect to it. And here we have two tables, books and setload. So I already added one book. It has the ID 1 and name is book 1. So let's also try to add some additional books. To add some additional books, we will use the post endpoint from our service end just with the body. So let's try to do this. So here you could find that in the response we got the 500 response status, and we had the internal server error. So in this case, let's check the database state. So in database, if we run the select again, we could see that we have only one book left in the database. So our book was not inserted. So let's try again the same operation. Maybe we will be lucky in this time, not. Let's one more time, still. So yeah, we got the response, and we've most likely created the book. Let's take a look. So again, if you run the query, now we have two books. So why do we have this behavior? Let's try to understand. The reason for such behavior is that in the save method we have some random behavior, and if based on some condition, we'll throw the exception, and with the transactional method, this exception will lead to not saving the book in the database. So here we have the transactional, and I think you most of you already know that transactional works with the EOP. So let's try to understand how does it work. So in our case, we did not do any special to enable the transactions in our project. So that means that since we are using the Spring Boot, we have some after configuration, we do this for us. And of course, in the Spring Boot, we have the transaction after configuration, which is the after configuration, which scans, which take a look at your class path, and if you have the proper class, this means that you most likely would like the transactional support for your application, and all those configuration will be enabled, and some beans will be also added to your context, application context, if you do not add this. At the bottom of this class, you could find some nested class, which also have two classes, which depends on the proxy target class. So you should know this property from the previous video, and based on the value of those property, false, true, or false, it will enable for your transaction management with the proxy target class with value false or true. So let's take a look what the enable transaction management. So as usual, this annotation works with the import annotation, and it imports the transaction management configuration selector. So what is this class? So this is the advice mode import selector. This is some abstract class which implements the import selector. So for import selector, you should know that we have the select imports, and here we have the mode proxy and aspect-j. So aspect-j means that you use the aspect-j for your proxy. In our case, no, we use only just the Spring AOP, only its proxy. So in the proxy aspect advice mode, we import two classes, two configurations to our context. Is the after proxy register and proxy transaction management configuration. So register, you should be already familiar with that from the previous video. It's the import bin definition register, which gives you the bin definition registry, and all that you do is just register after proxy creator if necessary. So in this case, it may register for you infrastructure advisor after proxy creator. So in our previous video where we saw that in AOP after configuration, we import the aspect-G aware advisor after proxy creator. So if you use only the enable transaction management, you will use the infrastructure advisor after proxy creator. So this is the proxy creator, which a bit has less possibilities and opportunities which aspect-J aware advisor proxy creator has. It's done for cases when, for example, you would like to use the transactions, but you still do not have the aspect-J in your class path, and you still would like to benefit from it. So this class is responsible for registering a special bin postprocessor, which will create the proxies for you in general. So since the transactional annotation works with the proxies, we firstly need the way how do we create the proxies in general. So here, this class will be responsible for creating the proxies, and also we have some additional configuration which is specific for the transactional annotation. So let's take a look at it. So it's configuration, just as usual, and several bins in it. So let's try to understand what all those bins do for us. First of all, this class extends some abstract transaction management configuration. Let's take a look at this configuration first. So here we can set the transaction manager. So if we would like, we could define the transaction management configures in the context, and in that case, transaction manager will be created for us. Also, we have the additional bin. It's transaction event listener factory. So this is the special event listener factory which allows you to use the transaction application. So it allows you to use the transaction event listener. So this is the really handful event listener, and if you do not know about the transaction event listener, I would like to recommend to read about this class. It's really interesting. So the next bin which we will take a look at is the transaction attribute source. So this bin is used by two other bins. So let's start looking at it. So in our case, we use the annotation transaction attribute source implementation, and this class is basically responsible for finding the transaction attributes for you. So here you could find two methods: find transaction attribute on the class and find transaction attribute on the method. So transaction attribute, this class defines specify which transaction you would like, which propagation behavior you would like, which isolation level you would like to have for your transaction, rollback on, defaults, read-only, timeout, and so on and so forth. So all those attributes will be gathered from the method or from the class, and you could find that all those works on the annotation parsers. So transaction annotation parser, and its annotated element is delegated to the parsers, and then you get. So we will not focus on it. If you would like, you could take a look at this. So you should just understand what is the transaction attribute. So next will be the transaction interceptor. So this is the bin where we use our transaction attribute source, and we specify it and just return it. So this transaction interceptor this class is the method interceptor. So this is our advice, the logic which will be added to all your transaction methods. So what do we have here? So in the method interceptor, the main method is the invoke. So your invocation will be delegated to this invoke method when like you intercept some method. And with this method invocation, you will decide whether to proceed to the next method or not. So in our case, since this transactional method only do some logic before and after your method invocation, we like always invoke the invocation proceed. So here we do some we like try to understand the target class and invoke within the transaction. So what do we have here? So first of all, we ask for the transaction attribute source. Then we get from this source the transaction attribute. Then we determine the transaction manager. So if we like do not set this transaction manager to this interceptor, we will get it from the bin factory. So it's just unusual. You just like add the transaction manager to the context and do nothing more like special. So then we like if we have the reactive support, it's not our case. Then we get the platform transaction manager, method identification, and do what we need. We create transaction if necessary. So if we like already have the transaction in our transaction manager, like if we do not have the transaction, we ask the transaction manager to like create the transaction for us. Or it could be, for example, attached to existing transaction and so on and so forth. Again, we will not like focus too much on this. You will always can take a look at this by yourself. So here, before like initially we create transaction if necessary, and then we do our proceed with invocation. It's exactly what we had in our method. So we invoke the invocation proceed. And after this, we complete transaction after throwing. So we'll like most likely we'll roll back in this case. If not, we just clean up the resources and so on and so forth. And if everything goes okay, we just commit this transaction after returning. So here, as you understand, is our method interceptor. So it's our logic itself, but we still need to define where we should apply this logic. So let's again get back to the our configuration, and here you could see that our transaction interceptor is also used in the bin factory transaction attribute source advisor. So this bin with the long name is the, as you most likely suggest, is the point cut advisor. So this is the main bin which you should like register in the context, and Spring OOP will understand it and will apply. So point cut advisor is the bin which should have two parts. First one is the point cut. In our case, it's the transaction attribute source point cut. It's just the thing which works with the transaction attribute source. And based on it, if you, for example, on the method, if you could like find any transaction attributes, it means that your like method and your class is eligible for applying additional logic. So this is point cut, and in our case, we also specify the advice itself is the transaction interceptor. So it's our method interceptor which will be used. And also, if we like have the enable ticks annotation attributes, it will also set the order. So by default, if you take a look at this advisor, it also implements the ordered interface, and here you could see that our order by default is lowest precedence. So that means that this transaction interceptor will be like the last in the chain. Okay, so now I think it's a bit clear how the transactions works. So it works mostly by enabling the proxy capability inside the application context in general, and also some additional configuration which just defines the method interceptor, which applies the transactional logic, and defines the point cut advisor, which specifies where this logic, transaction logic should be applied. So far so good. Okay, let's continue exploring our like typical application with the Spring and Spring Boot. So in most cases, when you define some controller and some endpoints in your application, you would like to get the validation for it. For example, in our findBook endpoint, we would like to set the ID of the books which you would like to find to 10 as maximum. In this case, all you need to do is to mark the controller class with the validated annotation, and then you could use JAVAX validation annotations to specify which rule you should apply for it. So let's try to test this. For example, if I try to get the books by ID with the ID 1, I will definitely get it. So it's my book 1. But if I try to get the book with ID which is more than 10, I will get the internal server error. So I do not write the handler for this, so I get the bad response here. But if we take a look at the logs of our method, you could see the constraint violation exception, and the find book ID must be less than or equal to 10. So how this works? Let's try to understand. Just as usual, since we are using the Spring Boot, we have some after configuration which applies all necessary configuration for us so that validated annotation will be work, and it's only if we do not specify this. And in our case, we have the validation after configuration class, which have the bin method validation postprocessor. So what do we have in this? What is the method validation postprocessor and how it works? This method validation postprocessor is mostly the filtered method validation postprocessor, and let's try to understand what is this class. Abstract bin factory aware advising postprocessor. So here we again see the bin postprocessor. So in previous video I explained what is the bin postprocessor, so I hope you remember this. And this class, this interface, has method postprocess after initialization. So let's take a look at this method. In postprocess after initialization method, we again get our bin and get the bin name. And if this our infrastructure bin, we just do nothing. If our bin is advised, we cast this bin to advised, and if it's not frozen and is illegible, so what is illegible means? So if we can apply our advisor and to our target class, we could do this. For advisor, we will take a look a bit later what is our advisor in this case. So if we need to add our interceptor before existing advices, we just to this advised bin, we add our advisor. If not, we just add it to the end of the chain. So advised, it means that this class is already proxied. So all proxied class, when the Spring Co-op creates it, it also implements for those classes advised interface, and this advised just represents the chain of interceptors in your proxied class. So if it's advised bin, you just add one additional interceptor to your already created proxy, and advisor, he is our advisor. Otherwise, if it's not advised, it means that our bin is not proxied. If it's, again, we check whether this an illegible bin, and it's all fallbacks to the same check. We use the proxy factory for it and create the proxy for us again. Pretty simple. Since in this case we either use the advised and just add the interceptor, or just create the proxy itself from the scratch, we need to understand what is the advisor and what is the point cut in our case. So let's get back to the filtered method validation postprocessor, and first of all try to understand where is our point cut and the advisor. So here in the after properties set, so when we initialized our bin, we specified the point cut and set it into advisor. So advisor, here you could see that it sits in the abstract advising bin postprocessor. It's the the union of the point cut and advice itself. So it's, in our case, it's default point cut advisor. So point cut in our case is the annotation matching point cut. So everything that is matching the validated annotation type. So if our class is annotated with validated type, it will be matched to our point cut. And what is the advice in this case? What the logic will be added to all those annotated classes? In our case, it will be the method validation interceptor with the validator or without it. So our method validation interceptor is again method interceptor, which has the invoke method, which do the simple things. It uses our validator, it's generate the executable validator, and this using this executable validator, we validate the parameters of our method, we validate the result of our method, validate return value, and so on and so forth. So we do the actual validation using the executable validator and the validator itself. So if we do not have this validator, we will get it from the bin factory. So you could see that all our class works based on the point cut advisor, where the point cut is the all classes that is annotated with the validated annotation, and the logic, the method interceptor itself, is something that works with the validator from the JAVX validation. If we already seen, this filtered method validation postprocessor is the bin postprocessor, which could either create a proxy for you or just add additional advice to your already proxied class. If we, for example, have the enable aspect-G annotation in our configuration, we will have the annotation aware aspect-G after proxy creator, which is also the bin postprocessor, which will create proxy for you. But why the filtered method validation postprocessing works and why it's not conflict with the annotation aware aspect-G after proxy creator. This is being handled by the order in Spring. So if you take a look how we register the annotation aware aspect-G after proxy creator, you will go to the EOP config utils, and here when we invoke the method, the register or escalate APC as required, and when we register the, for example, annotation aware aspect-G after proxy creator, when we register this to the our bin definition registry, we specify the property order as the highest precedence. So that means that the proxy, the after proxy creator which we have, will have the highest precedence, and it will be invoked the first, and it's create a proxy for you. But if you take a look at the filtered method validation postprocessor, and you will take a look at this get order method, so when we create this postprocessor in the after configuration, you could see that we do not set the order for this. So it means that it's used the default order which we have from the proxy processor support, and here the order is the lowest precedence. So it means that our proxy creator will be just the first, it will create the proxy for you, and then our filtered method validation postprocessor will be will see that the bin is already proxied and just add its advice to its proxy chain, and that's all. So I hope now it's a bit clear how the validated annotation also works. You now understand how the validated annotation works, and also you may already know that in Spring we also have the async annotation, we have the cacheable annotation, and all those annotation works basically in the same way as the validated annotation work, so we will not focus on it and just skip it, because you could, for example, take a look at the enable async annotation to understand and find all the classes which makes the async annotation work, and for cacheable you could find also enable caching annotation and also take a look at how this works under the hood. But we also have one more additional functionality in our service, is the scheduled method which counts the books, and it's triggered each 5 seconds. But we also have the scheduler lock annotation, which comes from the schedlock library, and this annotation says that if when you execute this method, you should get the lock for at most for 30 seconds and at least for 12 seconds. And this means that during holding this lock, we will not have more executions of this scheduled annotation. So this is really handy for the environments when you have several instances of your service, and this scheduler lock allows you to execute the job only once. As the demo of this scheduled annotation and the scheduler lock, you could see that we have the execution at the 11 seconds, and the next execution goes only on the 26 seconds, which means that this method, this log message should be shown each 5 seconds, but it's do not shown in that way. It shows only after 15 seconds. So at each execution we increment only the 15 seconds. So it's like skips the 2 more executions. So how the scheduler lock works? So it's of course it's not like enough to only specify the scheduler lock annotation. You need to say that you would like to enable support for this scheduler lock. And in this, how do we do this? We specify the enable scheduler lock annotation on our Spring Boot application. So it's like on our configuration annotation. And here we again have the import. In import we import additional scheduler lock configuration selector. What do we have here? It's import selector with the select imports method. So depending on what we need to proxy method or proxy scheduler, in our case we have the default value is the proxy method. In this case, we again import the after proxy register. So you should remember this class from the transactional support. So this class enables the creating of the proxy in general. And we also add additional lock configuration extractor. Lock configuration extractor configuration. Here we have the bin which will extract the configuration for us. So it's Spring lock configuration extractor. So not like too much interesting for us. We could skip it. And also we have the method proxy lock configuration. So here we have one bin which specifies the method proxy scheduler lock advisor. So this class is again the abstract point cut advisor. So this is the point cut advisor. And you already know this is the bin which specifies which point cut you should use in the advisor. So let's take a look what the point cut and what the advice in our case. So the point cut is everything that has the scheduler lock on the method, and everything with have the scheduler lock. This is two like annotation scheduler lock and another scheduler lock. So everything that any class that has any method with this scheduler lock annotation will be eligible for our point cut. And what is the advice here? So this advice is locking interceptor. Let's take a look. This is again method interceptor, which has the invoke method. And what do we do here? So invoke, we create the lock configuration, and invocation proceed will be invoked if our locking task executor could execute it. So here we get the result, and we will specify the either optional result or the result itself. So let's take a look at the locking task executor and its execute with lock method. So here we need its implementation. By default, we use the default locking task executor. So here we ask our lock provider to retrieve the lock based on our lock config. So here the optional lock. If lock present, it means that if we could retrieve the lock for this, we would like to lock execution of our method. We try to start the lock and end the lock. And once we get this lock, we execute our task. So this task call is basically the invocation proceed. If lock is not present, which means maybe this because it's already taken, we goes to this else, and in this case we do not execute. We do not invoke the invocation proceed, and our method is not invoked. So I think now it's a bit clear. So this is again works with the method interceptor, which works mostly with the lock provider, and just try to understand whether you could take your lock, and if so, if it's successful, you was the first who took this lock, you can execute your task. If not, then you will not be execute this task, and it will be just skip it. And as the point cut, we use everything that is marked with the scheduler lock annotation. So it's the thing which we usually see and we usually do. So SchedLock was my last example of the Spring OOP, which you could like explore by yourself and also learn something new from this usage of Spring OOP. So I hope now you like the topic Spring OOP topic became more clear for you, and now you like if you like haven't used the Spring OOP, you haven't wrote any aspect by yourself, you should definitely do this. You should understand more this topic and do not like scare the usage of OOP. Like do not think that this is the magic which is not understandable and like do something unusual. So I hope this topic is now clear for you, and I hope you enjoyed our Spring OOP journey. If so, of course, like this video and make sure you subscribe to our MGC channel to like get more such fancy video and learn a bit more about the Java and everything beyond the Java. So stay tuned. Bye.